right. So wanted to say good afternoon, FinDEVr. It's nice to see you all there. Not that I could see much in the lights here. My name is Robert Capps, as we were introduced from NuData Security. We're an award-winning behavioral biometrics company. On the stage here with me is Ryan Wilk. We're going to be doing quite a few little things today, talking about our product, specifically NuDetect, which is our flagship product that continuously verifies users' online identity based upon analyzing users' natural interactions. These are really interesting behaviors that really can't be stolen, replayed, or reused, and so they're not subject to data breach. Today, over the next few minutes, we're going to go through three different things. We're going to do a live demonstration of NuDetect running on a sample financial services environment. Live demos are fun from stage up here, let me tell you. We're going to dive into the technology behind the scenes. We're going to go through some of the steps. This is going to be new. If you've ever seen a presentation done by us, we've never gone through this level of detail with the product before, so this is new for you guys. It's new for us as well. And then we're going to go under the hood, and we're going to talk about a real-time model path. This is what makes the decisioning work for us. And again, really heavy detail here, and hopefully you get a good idea of what we're doing behind the scenes. So let's get started with the demo. Ryan, you want to take it away?
No, great. Thanks, Robert. So, perfect.
There you go.
So what we have here is we have a live version of the NuDetect platform. It's running on our new bank financial system. What we're going to look at is we're going to look at my ability to authenticate myself, but not just authenticate myself with my username and password. That's pretty easy. We all have that today. But really looking underneath the hood to understand not just are the credentials correct, but is it the actual correct human authenticating themselves into this account. I have a previously trained profile here. This profile is designed to look at the behavior of how I interact with both the machine as well as my actual input variables to be able to say, is it truly Ryan logging in? I'm going to log in quickly. We're going to take a look at what the results are. And then after I finish logging in, I'm going to let Ryan, I'm going to let Robert log into my account.
Already in there.
There you go. I'm going to let Robert log into my account, and we'll see what happens there, if it's actually able to verify that it's me or if it's not me. So first, let me start out here. So I've logged in. As we can see up here, I've received a strong biometric match, meaning that it's not only verified the credentials, but it's verified that it was actually me interacting with those credentials. So what I'm going to do now is I'm actually going to click into here, and we're going to take a look at our actual dashboard to get a bit better view of what went on there. So what we were doing was we were evaluating at how my input variables were actually going into the machine. As we can see, my username's right here, the device associated with this. One of the things that I forgot to mention a little earlier was this is a new device I've not used previously. As we can see down here, we're seeing that I had a new device and a new IP address associated with this interaction. But I was able to authenticate myself. I did receive a strong biometric match. As we can see here, I was able to authenticate myself. We have our biometric visualization here, the green line being a perfect input pattern for Ryan, and the white line being the actual input pattern for this particular attempt. So now what I'm going to do is I'm going to let Robert log into my account, and we're going to see how that turns out. But what I'm going to do now is so much of today's systems are based around the device. So I'm going to make this a trusted device for my account now. So we can take a look to see, is it really me or could it potentially be Robert? So what I'm going to do now is I'm going to load up a new window here, and I will give Robert my username and password, and I'll let him log in.
Oh boy, I see our security hasn't increased since FinDEVr. All right, so Ryan at wilk.net. PASSWORD at 1, because it's got to be secure.
It does.
All right.
Okay, so look at that. So Robert did use my correct username and password, but he did not receive a strong biometric match. He received an unlikely biometric match, meaning that there was a low probability it actually was Ryan. So again, what I'm going to do is I'm going to click into the dashboard, and we'll take a look at this quickly. So as we can see here, the login was prevented, but it was a valid credential being used. It was a known IP since I logged in successfully on it just a moment ago, and it's a trusted device since I marked it as a trusted device. But as we look at the biometric match, we can see how far that falls outside what was expected. Again, that green line being the perfect input pattern, and those red lines being a visualization of kind of the top and bottom of the extremes of what would be acceptable within that pattern. And we can see how that white line falls far outside of that. So now that we've taken a look at the actual demo, let's dig in a little bit more into the technology and understand what the technology is doing that allows this to occur. Okay.
Desktop too.
Perfect. Okay. So what's happening, as I'm interacting with either a web device, a mobile device, an API, we're collecting lots of different data elements, lots of different features around how I'm interacting. If it's a keyboard and a laptop, looking at how I'm typing, things like type speed, type deviation, do I appear to be right-handed or left-handed? If it's a mobile device, how am I actually spatially holding that? What are the accelerometer readings saying? Is the phone tipped in such a way that I'm a right-handed typer? Is it tipped in such a way that I'm a left-handed typer? Or do I type in portrait mode? So really learning getting a better understanding of how that user's interacting with that device across all the different device elements. We then layer in previously known information around that user. So each time that user returns to the site, we're collecting all of these different features around how they're interacting, and we're building out a profile. So we're able to build in the historical understanding and the historical profile around how this user's interacted. And then along with that, we're looking at the full population. So we can look at just that user, but it's also very valuable to look at what the full behavioral population is doing to better understand, is there some sort of anomaly or is there some sort of risk associated with this when behaviors start to collide and start to work together in mass. Then, as we're collecting all of those features, they're going through various different funnels, and those funnels are looking to understand what is the best feature set for this particular user at this point in time. As you can imagine with any model, certain data points become rather useless if there's a high collision rate. So we might find that a certain data point is giving us a 100% match across all users. Well, that data point becomes isn't very useful for that particular evaluation. So we're taking all those data points, all of those features, things like I was saying, the accelerometer readings, type speed, various things like that. We're filtering those through and determining what the key features are for those users. So these are the key data elements that are most valuable for that particular user at that point in time to be able to create a strong match or a strong understanding of who they would be. Those features then flow into our behavioral model, and that's what turns into the full behavioral understanding and the behavioral profile of that particular user. And what's that do? The outputs of those are both endpoint confidence, so understanding what the likelihood, the device and connection profile link back to that user historically, then also looking at the biometric confidence, that actual passive input we've collected within the machine to better understand what's the probability it is that user. And that really lets you do two really important things. It lets you both validate that it truly is the correct user authenticating into the system. Then it also allows you to know when it's not the correct user, when there's various different anomalies, things like account takeover, new account fraud, or automation, when those behaviors start to work in mass and they're working in mass in a risky way. So kind of pulling this all back together, what we're seeing here is the funnel goes that we start out collecting lots of data points around that user, lots of features around how that user's interacting within their device, whether it be the mobile device, the web device, or the native app. Taking those features, funneling them through that filter to understand which features are most valuable for that particular user at that point in time. Taking those key features, turning those into the biometric model and the behavioral model and make those determinations of what's the likelihood it truly is that user. Finally outputting into that confidence score of, is this the correct user or is this potentially someone creating risk? So now that we've looked at this at a high level, I'm going to turn this back over to Robert and let him dig a bit more into how the model actually works.
Oh, modeling. So we're going to go ahead and get, ooh, what happened there? Oh, we both hit the button at the same time. Okay. Double input. So getting into that behavioral biometric model, this is, what you're seeing here is the NuDetect real-time model path. This is the decisioning engine that does all of the analytics in real time for our customers. What we do in about 50 milliseconds is we take in all of those data points that Ryan was talking about, all those features that are derived from the current session. We take those features, these key features, we read them into a real-time model runner. That runner also has access to real-time caches within our production environment that are read optimized so that we can pull in historic data about this user and the customer populations. And we turn that around, again, in about 50 milliseconds and spit that as a score back out to our customers. And we do this for a number of different types of models. This is just the biometric model we've been talking about. All these are calculated in real time and provided back to the customers as intelligence. Once that's complete, there's some additional stuff that happens behind the scenes. So we're taking all of the current data, all the current transactional data, and we're pushing that through a historic profile builder. That process creates intermediate data sets that are then pushed to our model builder that pushes data back out to our cache and stores the longer term data in our data warehouses. What what's important here is that we're subdividing all that data into very different tranches of data that are stored in different ways. But, and this all looks familiar to anyone who's built a data modeling system before. This is pretty standard. What's really special here, what we've done to make this easier on our data scientists, is we've actually built an abstraction layer which we call iModel. Now, our iModel process allows our data scientists to access data without having to write much code at all. In fact, they could use standard methods that we've created for them to access without having any regards to where that data lives within our system, whether it's in the nearline data warehouse or it's in the online read-optimized cache, or it's coming in the front door as part of the data stream from the analytics. They don't have to worry about that stuff. All of it's been abstracted to the point where all they have to do is think about data. How do you build a model? What methods do you want to use to build that model? What technologies do you want to do to build that model? What's interesting there is that gives us the unique opportunity to have our data scientists think purely in data and start to focus in on technologies and models that we've never seen before, that we've never used. They can use whatever tools come to mind that are germane to the model they're trying to build, and they can extend our product set in ways that we've never thought about. And we can do this in a very, very rapid fashion. Something's not right here. Anyway, so we do this in a very rapid fashion. We can iterate through our products, and we can extend the capabilities very quickly. Now, this wouldn't be a FinDEVr if we didn't have a sample of code. So here's our obligatory sample of code. This is, I got a couple laughs out of that one. This here is actually an example of how one of our data scientists could invoke a model run using 4 distinct features. We've got, and I don't really have a pointer here, but you see feature sorting right there. They can invoke the sorting of all the features that are coming inbound. They can build out a user profile and populate it with the correct features. They can do selection, historical data selection and population into the profile, and then they go through a scoring process in that small amount of code, using whatever modeling technology they wanted to use. And so this really does extend their ability to produce models and extend our product in ways that we've never really thought of. The key piece here is that we want our data scientists building models, not writing code. Anybody else have that problem? Yeah, that's what I thought. So sort of closing out as we're getting near the end here, so talking again about the full feature set. This whole entire stack that we've produced gives us the ability to accurately identify good users with a high degree of confidence while providing actionable intelligence on interactional risk. Now, when you think about once these good users are identified, once we've figured out who the good users are, all the other technological attacks that are available, such as identity theft, account takeover, new account fraud, and automation, become very easy to deal with in this framework. So I know we're getting close to, I see them putting the bar together out there. I feel bad for the next guys that are up because they're the last ones before drinks. But so I want to thank you guys all for your time. If you'd like to chat about the solution in a little more detail, please come by our booth. We're just outside the door there. And we'll talk to you guys soon.